So the two traditional methods widely used for doing any kind of warping are forward and inverse. We briefly touched on them in the last lecture. I'm going to now just give you more details on them. So to help us understand this, let's start off by just having two images. We'll call the first image the source and the T the target. We want to be able to take information pixels from the source and create a new image or a target image that would have the deformations or the warps that we are interested in. For simplicity's sake, let's imagine S basically has a coordinate space u and v, and the target has x and y. Now this is slightly a different notation than we've used so far. In the previous ones we talked about S being basically x and y, and the target being x prime and y prime. Just bear with me for a second, we'll come back to that notation in a bit, but this is just to kind of help us understand how we can do this simply. So forward warping basically is generating a new x and y by creating a warp on x, which is applied to u and v here, and warp in y, which is also taking u and v from this one and generating a new set of coordinates x and y. So here, of course, the warp is x and y applied to the values in here and generating this. Backward or inverse is basically trying to do a prediction of where things are in the target based on what are things or pixel values in the source. So here, of course, we're generating, in essence, the u and v by doing a deformation or a transformation or a warp, u and v, which takes values from here and generates this image. So in essence, while we have this, we're trying to now do the opposite of trying to figure out how to go from pixel values and all of the range values here into this one. To help understand this, let's take a simple example. Now this was, of course, what we want to accomplish for forward, and this is what we want to accomplish for inverse. Here I'm basically showing an input and output for basically the forward, and the input and output for the backwards or the inverse, and the input and output for the inverse warp. Now, to help us along, what we can actually start imagining is that this could be UV could be completely integer values. It'll become clear in a second, while the output needs to be in real values. While in the case of the inverse warp, the opposite is true. If I had all of this in integer values, I could actually now have real values input image. Let me start off by finding a few pixels in the original input here and see what they would look like in the output. Here is one, and here's the other one. When this pixel is moved over, the information from this pixel is moved over to the output, of course, because of the warping, it won't be just in the regular grid pattern of this image anymore. In fact, the intensity values should be distributed in the raster scan of this image. And of course, what we now need to do is generate a new image that would have the values that came in from here. And again, the warp would be based on these two x and y. And imagine this is now, of course, moving here. So in essence, what we've got is from here to there, actually we've warped the image, and from here to there, we've warped this part of the image. This region is now moved here. So this is basically the forward warping process. In the case of the inverse, the opposite is true. We would have this region, we want to move it here, and we would have another one. So again, let's take these two pixels. Again, these are integer values and all of the values that come from it, and we want to try to move into this range. Now let's talk about the problems. The big problem when we do a forward warp is, in this instance, I moved all of the information to a warp region here. And of course, imagine if there is another pixel or region here, then I want to do it here. Of course, if it moves here, there might be a cause for an overlap. Of course, it also is possible that this region here next to it moves here. And of course, all of a sudden, I have no information connecting these two parts here. So of course, this would be a hole. So overlap would be they go next to each other, overlapping in the information, or in this case, when they're far away, there would be a hole. So this is one of the problems when I go forward. In the other end, when I actually am going backwards, that is doing the inverse warp, I know that these pixels belong to here. But the problem that comes in is when I actually start going for something that becomes smaller, or the minification process. I'll show that in a second. And that would result in all kinds of artifacts. One of the bigger artifacts in these processes, of course, is aliasing or blocking.